Good evening, dear students. Today we will start a new topic called, mathematical reasoning. Okay. This is an interesting topic. Um, why it is interesting? Let me explain you. But before that, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students? Can someone
Yes,
of you confirm? Thank you. Thank you very much. So, why this is an interesting topic is that all of us know that human beings evolved from the lower species over many millennia. The main asset, what the human beings is having, or I can say the main asset that made humans superior to the other species was the ability to reason. How well this ability can be used depends on each person's power of reasoning. How to develop this power? Here we will discuss the process of reasoning, especially in the context of mathematics. In mathematical language, there are two kinds of reasoning. One is called inductive and the other is called deductive. Inductive reasoning is actually we discussed when we discussed about the principle of mathematical induction. Okay. Here what we will discuss the some fundamentals of deductive reasoning. Clear, dear students? So, what I can say about that mathematical logic is that mathematical logic is a study of general pattern of reasoning, okay, without reference to the particular meaning or context. And as time goes by, we will see that how this particular statement is actually getting realized. So, dear students, so as you see in the screen, that what I wrote about mathematical logic is that mathematical logic is a study of general patterns of reasoning, okay, without reference to the particular meaning or context. We'll come to this particular, these two are very important things. Without reference to particular meaning or context. Okay, dear students. So, first thing is that what you need to understand about the statement. So, we are going to learn about that what is meant by statements. Dear students, if you look into the statements in the context of mathematics, a statement is a sentence which is either true or false, but not both simultaneously. Okay, so we will consider this is a foundation of our further discussion. What is that? A statement is a sentence which is either true or false, but not both simultaneously. Okay, it could be, the statement could be either true or it could be false. Okay, either the statement is true or the statement is false. It cannot happen that both it is true and false at the same time. That means simultaneously. Okay, let us consider few sentences, and then we will get it more clear. Okay, here it is. Few sample examples of statements, and let us see how we can infer whether it is true or false, and anything else we can infer from it. So, as you see, dear students, in the digital board, that let us consider the following sentences. The first one, the first sentence, if you see, dear students, that New Delhi is the capital of India. New Delhi is the capital of India is a statement. As the fact mentioned in this statement is true. So this is the first one. Second one, let's look into it. The sentence, something like every quadrilateral is rectangle, is a statement. Okay. And as the fact mentioned in the statement is false. So that is a statement, but it is a false one. Okay. Correct? Let me repeat the sentence. Every quadrilateral is rectangle is a statement as the fact mentioned in the sentence is a false one. Let's look into the third one. The sentence like "open your eyes" is not a statement as long as the mathematics in the context of mathematics, as the fact mentioned in the sentence cannot be assigned to true or false. In fact, this sentence is a command. Open your eyes, is not a statement. It is a sentence, but more than that, it is a sentence. This sentence is a command. But if you look into the fact mentioned in this, sentence, is not true to false. So here there are two important things, dear students, and you should not mix up. One is the statement, and second one is the sentence. Okay. A sentence can qualify to a statement if the fact of that sentence is either true or false. If the fact of the sentence can't give you a proper conclusion of whether it is true or false, like "open your eyes," the example, that is a sentence, but that doesn't qualify to a statement. Whereas if you look into it, New Delhi is the capital of India. That sentence qualify to a statement. Why? Because the fact mentioned in that sentence is a true one. And the other one, that every quadrilateral is rectangle, that sentence qualify to a statement. Why? Because the fact in that sentence, the facts in the sentence, facts in the sentence is a false one. So it is a statement. It's a statement, but it is a false one. New Delhi is the capital of India. It is a statement that is a true one. The facts mentioned in the sentence is true. So I hope you got a very clear idea about the statements. So before I proceed further, let me tell you once more. A statement is a sentence which is either true or false, but not both simultaneously. Correct, dear students? Now, let me go to the next discussion, that there are classification of statements. Okay, there are simple statements and compound statements. Okay, so let me give you some example and more about simple statements and compound statements. And let me first give you the portion of from our study material, and after that let me explain you. So as you see, following are the different classifications of statements. The first one, simple statements. A statement is called a simple statement if it cannot be broken down into two or more statements. Whereas a compound statement, a statement is called a compound statement which is made up of two or more simple statements. So that is the foundations of simple and compound statements. Now, dear students, what we are going to discuss, we are going to discuss about some basic logic connectivity. So we are going to discuss now some basic logic connectives, and I'm going to discuss this thing in the next page. So, dear students, the words which combine or change simple statements from new statements or compound statements are called connectives. So what are connectives? Let me first describe you the definition. After that, we will discuss further. So as you see, dear students, that the words which combine or change simple statements to form new statements or compound statements are called connectives. Let us see from some basic connectives, and then we will see that what are the meaning of those connectives like conjunction, disjunction, and negation. So, dear students, I'm just going to place the following table, and you just need to look into this table, and that they are you know the symbolic notation. So the first connectives is called the conjunction, and its English word representation is and its symbol notification, as you see, is and is like this, as I'm writing it here as well, like this, that is and. Whereas the disjunction, is represented by the English word as or, and its symbol notation is, if you flip that symbol notation of and or conjunction, you will get this. And the third connectives is the negation, dear students, and it is denoted by not. Okay, and what you can do is that not is the negation, and it is denoted by this thing. Okay, dear students, so as you see, the basic logic connectives we discussed. Okay, please note that the connective negation actually does not combine two or more statements. In fact, it only modifies a statement. We will see all these things in the subsequent discussion. But for your information, let me just mention this thing here, dear students, is that the connective negation actually does not combine two or more statements. In fact, it only modifies a statement. So dear students, so now what I need to discuss is called the conjunction. Okay, and before I proceed further, just give me a second. Okay, dear students, so now let's continue. So now we are going to discuss about conjunction in details. So, and I'm going to take you to the next page to discuss about this thing is in conjunction. So dear students, if two simple statements are connected by the English word and the resulting statement, whatever the resulting statement we get, that is called the conjunction of those two statements. And dear students, we can represent a statement by by letter, and then let's see that how the conjunction is actually going to work. As you see, dear students, if two simple statements P and Q, if two simple statements P and Q are connected by the English word and, then the resulting statement P and Q is called a conjunction of P and Q and is denoted by the symbol P, the conjunction, that symbolic notation P, then that's that notation and notation and Q. Correct, dear students? And if you see that P and Q are two statements, statement means that what? They are sentence which the fact value of those sentences is either true or false. So let us take a couple of examples. Okay. In fact, we take the first example is that let us take these two statements and symbolically, their representation, we call it as P and Q. So what is the first one is that, let us take these two, that P represent that Arjun is a boy. P represents Arjun is a boy, and Q represents Priya is a girl. Now, the conjunction of the statement P and Q is denoted by P and Q, that is the symbolic notation of and. Okay, and the corresponding statement will be what, dear students? Arjun is a boy and Priya is a girl. Now, so let me write it down here. Now, the conjunction of the statements Now, the conjunction of the statements P and Q is denoted by P and Q, and the corresponding statement is Arjun is a boy and Priya is a girl. Correct, dear students? Now, as long as the truth value of the conjunction P and Q of two simple statements P and Q is concerned, we conclude something. Okay, what are those? Let me first bring this to notation in front of you, and then we will discuss further, and that will lead us to construct a truth table, dear students. Okay, so what I was telling is that now, as long as the truth value of the conjunction P and Q of the two simple statements P and Q are concerned, we conclude the following. The first one is that the statement P and Q has the truth value T whenever both P and Q have the truth value T. The statement P and Q, I repeat, dear students, the statement P and Q has the truth value T. Okay, whenever both P and Q have the truth value T. The statement P and Q has the truth value F whenever either P or Q or both have the truth value F. Okay, these are very important statement. Either P, either or both. Okay, these are very meaningful statement. And for the previous statement, and is a very important statement. Very important, a word here actually, more than a statement. So let me now, as we understood this particular two information, what we can say now, we can find the truth table of that conjunction, and I'm going to show you the truth table of the conjunction is something like this. Okay. So here is the truth table of the conjunction. Okay. Is that truth value of P, truth value of Q, and truth value of P and Q. If the truth value of P is F and truth value of Q is F, then truth value of P and Q is F. If truth value of P is F and truth value of Q is 2T, then the truth value of P and Q is F. If truth value of P is T and truth value of Q is F, then truth value of P and Q is F. If truth value of P is T and truth value of Q is T, then the truth value of P and Q should be T. Now, dear students, let's have a look into these particular two statements. I just want to go back to these two statements once more. The statement P and Q has the truth value T whenever both P and Q have the truth value T, and that is exactly what is mentioned here, dear students. Exactly, if you look at here, this is exactly mentioned here, right? I repeat this statement, dear students. The statement P and Q has the truth value T whenever both P and Q have the truth value T. So let me, mark this statement, and what has been represented by this in the truth value, that is the last row in the truth table. So this is the last row in the truth table is actually representing the first statement. Now let's look into the next statement that I can do it in the purple color. The statement P and Q has the truth value F whenever either P or Q or both has the truth value F. When either P has a truth value F, this one, or Q has a truth value F here, or both P and Q has a truth value here. So dear students, so if you look into this statement, this particular statement here, okay, that is represented by the first three rows of this truth table. I hope it is absolutely clear, dear students. And in physics, dear students, I'm just bringing the topic of physics here. In the logic gate, if you look into the AND logic gate, which you will be studying later in that in your next year, you will study about this, truth table of logic gate. There also you will get the same thing, that when both P and Q are true, then you get that P and Q is true. If any one of these is false or both are false, then the value of P and Q is false. So this is all about, dear students, is called the conjunction. Now, dear students, what we can discuss is that we are going to discuss about the next connectives, and that is called the disjunction, and that I'm going to discuss in the next point. Okay, dear students, and I'm going to discuss this in the next page. So this is what is called the disjunction. So this is a header. So dear students, if two simple statements P and Q are connected by the English word or, then the resulting statement P or Q is called a disjunction of P and Q, denoted by the symbol P or Q. If two simple statements P and Q are connected by the English word or, if two simple statements P and Q are connected by the English word or, then the resulting statement P or Q is called a disjunction of P and Q, is denoted by the symbol P or Q. Okay, is denoted by the symbol P or Q. Okay, so that is the disjunction, the fundamental definition of disjunction. Now, dear students, so let's take the following two statements represented by P and Q respectively. Okay. So, and we will see what is the meaning of P or Q. So here it is, dear students. So I take two very simple statements, very simple statements. For example, let us take the following two statements like that. P is, India is in Europe, and Q is India is in Asia. Now the disjunction of the statement P and Q is denoted by P or Q, and the corresponding statement is India is in Europe or India is in Asia. And we'll see what is the truth value of that statement P or Q. That is, India is in Europe or India is in Asia. You see, dear students, the truth value of that statement is T. Why? Because India is in Asia. Okay, we know, but how this disjunction is actually working in context of the mathematical logic, that we are going to discuss now with the formal definition followed by the truth table. As long as the truth value of the disjunction P or Q is concerned, okay, we conclude that statement P or Q has the truth value F whenever both P and Q have the truth value F. And the statement P or Q has a truth value T whenever either P or Q or both have the truth value T. Okay, so let me write down this statement. Whatever I just said, let me write it down. Okay, so this is the first part of the statement, dear students, and I'm going to tell you the next part of the statement. Okay, the statement P or Q has the truth value F. Okay, whenever both P and Q have the truth value F. The statement P or Q has the truth value T whenever either P or Q or both have the truth value T. Let us, construct the corresponding truth table, and we get the truth table is like the following. Okay, let me place the truth table in front of you, dear students. After that, I'll explain once more, and I'll come back to the statements as well. If you look into this, truth table, that when we see the truth value of P is F and truth value of Q is F, then the truth value of P or Q is F. Apart from all the other three cases, that means when truth value of P is false, F, and truth value of Q is T, then the truth value of P or Q is T. When truth value of P is T and truth value of Q is F, then we see the truth value of P or Q is T. When truth value of P is T and truth value of Q is T, then we see the truth value of P or Q is T. You may have a question. Sir, is it the only 4 combinations or any other combinations possible? Dear students, go back to your permutation combination days and recall those lectures. So there are 2 values P and Q. It can take, there are 2 positions. Each position can be filled with either T or F. In how many ways you can do? It is 2 to the power 2, that is 4. FF, FT, TF, TT. Now out of these 4, dear students, if you see, if I take a different color, that so the statement P or Q, if I take this one, the statement P or Q has the truth value F whenever both P and Q have the truth value F. And this particular statement, what I just marked in the blue color, is represented by the first row of the truth table, dear students. I hope you agree to me. Any smallest clarification, never hesitate to let me know. And if you look into the second statement, which I can take in the purple color, the statement P or Q has the truth value T whenever either P or Q or both have the truth value T. That means what, dear students? So if we take this one, the last 3 rows is actually represented by this one, these last 3 rows. Okay, dear students, so I hope you got a very clear idea about these statements, and the first one is represented by this. Okay, dear students, so I hope you got a very clear idea about the disjunction as well. Now, our next point of discussion is the negation, and that I'm going to discuss with you now. Okay, so that I'm going to discuss you in the next page. And I will take you to the next page and discuss about the negation. So let P be a statement. An assertion that a statement P fails or denial of a statement is called the negation, okay, of the statement, and denoted by that, tilde P. So let me just write it down, and let me then followed by I will explain you. Let P be a statement, okay. An assertion that a statement P fails or denial of a statement is called the negation of the statement and denoted by tilde P. So let us take example so that we can have a very clear idea. Let us take the statement like a Kolkata is a city. Okay, now we will see that what we can infer from the negation of that statement. Okay, so what I was telling dear students is that let us take that following statement like the Kolkata is a city that we are representing by this, by P. Okay, now the negation of the statement P denoted by the tilde P, as you see here, tilde P, and the corresponding statement is either of the following: that Kolkata is not a city, or you can say it is false that Kolkata is a city, or you can say it is not the case that Kolkata is a city. Okay, we'll come back to all these things in details. So, but I hope you understood that these are the three statements we can infer. These are the three statements we can infer from it. Now, as long as the truth value of negation of P is concerned, what we can say, dear students? We can say something like this. First, let me place this in front of you, and after that I will discuss. As long as the truth value of the negation, tilde P of the simple statement P is concerned, we conclude the following. The first one, the statement tilde P is the truth value T whenever P has the truth value F. And the statement tilde P has the truth value F whenever P has the truth value T. Okay. So now as we understood this thing, what will be the, truth table? The corresponding truth table will be pretty simple. Okay. And the truth table will be something like this, as you see in front of your screen, dear students. That whenever the truth value of P is F, you get the truth value of tilde P, the negation of P is true, T. And when you see the truth value of P is T, we get the truth value of tilde P as F. I hope it is clear, dear students. In fact, if I say the first statement, the statement tilde P has the truth value T whenever P has the truth value F, this is actually represented by the first row. Correct. The first row of the truth table. Okay, so this one. And if you look into the second statement, if I use in the purple colored, the statement, tilde P has the truth value F whenever P has the truth value T, that is represented by the second row. Okay, and it is represented here. Now, dear students, so this is all about that, the three, important points. What I want to discuss is the, three connectives: conjunction, disjunction, and the negation. So now I would like to conclude the class here. In the next class, what we will do is that we will discuss that, the negation of compound statement. Then we will see the compound state conditional statement, and then we'll discuss about the contrapositive of a conditional statement and converts of a conditional statement. Then we will discuss about the biconditional statement, and after that we will discuss about the quantifiers. Then finally we'll discuss about the validity of statement. Okay, like the validity of a statement with and, validity of a statement with or, validity of a statement with if then, and then you will discuss about the validity of a statement with if and only if, that is denoted by IFF. All this, whatever I said in the last 1 minute, we will be discussing in our subsequent classes. So with this, dear students, I would like to conclude the class here, unless you have any specific